Welcome to this programming tutorial. In today's tutorial, we're going to look at recursion. Recursion is when you have a subroutine, often a function, which calls itself. It's similar to iteration, except I want you to think of recursion as a spring that you compress and compress. And once you've compressed it enough, you then let it go for it to expand again. For recursion to work, you have to have three parts to it. One, a base case. This is a condition within a subroutine that stops the recursion. Two, for any input values other than the stopping condition, it must call itself. So in other words, any input values must call itself, unless it is a stopping condition. Thirdly, the stopping condition must be reachable after a finite amount of times. So you cannot have a recursive algorithm that is infinite. Now let's look at an example of this. If I create a simple program here, we'll have count equals 0, and we'll say for I in range 0 to 10. And I'm going to I'm going to increment counts by doing count equals count plus 1. This is a very simple algorithm, but let's look at how we can develop this algorithm the same way, but using recursion instead. We'll do def counter to create a function, and we'll take in a count variable. Then we'll say if count is greater than 9, we're going to return the count. Else, if the count is not greater than 9, then we're going to return the counter with the count plus 1. So what are we doing here? If I write it as counter 0, count equals 0, and because count is not greater than 9, we're going to return the counter function with an increment of the counter. So that increment is going to keep going and going and going and going until it is greater than 9. And that way, it'll stop with our stopping condition, or what's known as our base case. Let's run this program and see it working. I'll also output this function so we can actually see the output. There we go. We end up with 10 because that's where the base case stops. How else could we use this? Let's look at an example when it comes to factorial numbers. For example, if I had 3 factorial would be known in maths as 3 times 2 factorial, which is going to be 2 times 1 factorial, which is going to be 1 times 1. I've also written the exclamation marks in the wrong place, so let me fix that right now. This gives you an idea of how recursion works. We have a subroutine that consists of another subroutine that consists of another subroutine. And that's how you have to think of it. That's the difference between recursion and iteration. So let's develop a factorial function. We'll define factorial with n, and we first need to discover when we stop the recursion. In our previous example, we stopped the recursion when we reach 1, because we can't go any further than that. So let's define when n equals 0, we'll return 1. Else, what we're going to do is we're going to return the sum we created before. Remember, I'll write it out again. We've got 3 factorial is going to be that times 3 times 2 factorial, which is going to be that times 2 times 1 factorial, which is going to be that times 1 times 1. So in this case, we can see a pattern here, which is n times the factorial. So let's write it over here. If I change the 2 to an n, or change the 1 to an factorial of n minus 1, we have our algebraic expression over here. So let's write it over here. N times the factorial of n minus 1. That should get us all the way down to the end of our algebraic expression over here. And when it returns 1, what we should see is this start to fill up and go all the way across till we reach our desired 3 factorial. Let's try this out. And I'll print out factorial of 4. And there we go. 4 factorial is 24. Recursion is very useful, and it can be a little bit difficult to understand at first, but you have to remember it's like a subroutine calling itself and then coming out bit by bit by bit. It's like a spring. You start compressing it and compressing it until with more and more subroutines until you get to a base case, and then from there it starts building upwards and uncurling or uncompressing the string, doing the calculations each time until you reach the original one that you created over here. Thank you for watching this tutorial. I hope you found it helpful.